Hello everyone. In this video we are going to look up at some of the important questions for OMEA from University of Delhi exam point of view. These are some questions whose concepts everyone should know. Let's look up at the first question. Now find dy by dv if y is equal to v square minus 4v plus 9 raised to the power of 12. So we need to find out the differentiation of dy by dv. In this we are going to apply the chain rule. Dy by dv is equal to, by using the chain rule, it is raised to the power of 12. So 12v square minus 4v plus 9. It is n minus 1, so 11. And then we are going to differentiate what is given there in the brackets to us, which is 2v minus 4. So this is the solution for this differentiation. The formula that is used in this is n x x raised to the power of n is nx n minus 1. So and if something is given there in the brackets, we further differentiate it. So you get marks for writing the formula and also for giving the right answer. Next, as you can see, a similar question, dy by dx if y is equal to x cube minus 5x plus 2 raised to the power of 10. How do we solve this? Dy by dx, again by using the chain rule. Ten x cube minus 5x plus 2 raised to the power of 9, and then further multiplying it, whatever is given there in the brackets, differentiating that is 3x square minus 5. So this is the final answer. So the chain rule concept is something that you should know. By using the basics rule of differentiation, how do we solve a chain rule differentiation? Let's look up at the third example. Third question that is there, question number 3. The demand function given q is equal to 80 minus p square. You need to find the price elasticity of demand at p is equal to 4. Now this is a concept of applications of microeconomics. By using the formula ED is equal to dq by dp into p by q. Now how do we find dq by dp is nothing but the differentiation of q with respect to p. So if q is given to us as 80 minus p square, we are going to differentiate it with respect to p to get dq by dp. If you differentiate it with respect to p, you will get minus 2p. The inputting in the formula of dq elasticity, price elasticity of demand. But for that, before we need to know what is the quantity q at price equal to 4. So at p equal to 4, q is equal to, put in the equation, q is equal to 80 minus p square, which is 80 minus 16. So this is 64. Now q is equal to 64, p is 4, dq by dp is minus 2p. So we put in everything in this formula and we get ed is equal to minus 2p multiply by p, which is 4, divided by q, which is 64. Now we put in the value of p as 4, we get minus 8 4 by 64. We cancel it and the final answer we get is minus 0.5. Now they could also ask you to comment what type of elasticity is this. Remember, by ignoring the signs, this minus sign is ignored, and if ED is less than 1, it is inelastic. If ED is equal to 1, it is unitary elastic. And if ED is greater than 1, it is elastic. So in this case, the answer is minus 0.5. We ignore, whenever you look up for you are telling about the elasticity, whether it is inelastic, unitary elastic or elastic, you ignore the minus sign. So you only going to look up at the numerical value, that is 0.5, which is less than 0. So in this case, it is what type of elasticity? It is inelastic in nature. That means with the percentage change in the prices, the change in the quantity demanded is less than the change in the prices that is happening. So demand is inelastic. So this is one type of the question that you should know the concept by using the concept of microeconomics. Let's proceed to the next question. So this is next question, which talks about that there are two goods, burgers and fries. The profit function is given to us. The subject to capacity constraint, the budget constraint is given to the capacity constraint is given to us as x plus y equal to 20. We need to find two things: find the profit maximizing output mix and the effect on profit if capacity is increased by 1 unit. So we know the solution. We are going to first set up the Lagrange. How do we set up the profit function given to us? 60x minus x square minus xy minus 2y square plus 80y minus. Now we are going to use up the lambda plus lambda, this subject to budget constraint, capacity constraint given to us. So this is 20 minus x minus y. Do remember that we always set up the Lagrange like this. We put in the profit function or the whatever the objective function given to us, plus we write the lambda, and first we write the constant and then the variables given to us. So this is always expressed, x plus y will come up to this side and it will become 20 minus x minus y. This is the important aspect over here that needs to be remembered in setting up the Lagrange. So this is now what we are going to do. We are going to the first order conditions required. The first order conditions required. The differentiation of this Lagrange with respect to x, with respect to another variable y, and with respect to lambda, that all should be equivalent to 0. The first order conditions require simultaneously all this should be 0. So now first finding it with respect to x. We are only doing the differentiation of the Lagrange multiplier with only one variable, that is x. If we do differentiation, this is 60 minus 2x minus y minus lambda, putting it equal to 0. Let's name this equation as equation 1. From here we get expressing it in terms of lambda, so that when we further solve it, it is easy for us to do. 60 minus 2x minus y. Next is delta L by delta y. So this is step 1. And in the exam, always write clear steps, clear formulas. For everything you get marked delta L by delta y. So this is 80, doing it with respect to only y variable. So minus 4y minus x minus 4y plus 80, and with respect to lambda it is minus lambda. Now putting it equal to 0, we get, again solving it in terms of lambda, we get lambda is equal to 80 minus x minus 4y. Let's name this as 2. This equation was 1 instead of this one. Yeah. So first equation, second equation. Then next is doing it with respect to lambda. Now if we do it with respect to lambda, we are getting 20 minus x minus y, because all others are constant for us. Only with respect to lambda we get 20 minus x minus y. So delta L by delta lambda is 20 minus x minus y. We set all this also equal to 0. Let's name this as third equation. Now solving, second step, solving 1 and 2 simultaneously, we get 60 minus 2x minus y equal to 80 minus x minus 4y. Now if we solve it, 80 minus 60, 20 and minus 2x, so this is going to come out as x is equal to 3y minus 20. Using third equation, using third identity as well, we are going to get 3y minus 20 minus x equal to 20 minus x minus y. So 4y is equal to 40, so y is equal to 10. If we put y is equal to 10 in any of the identities 1, 2 or 3, we are going to get x equal to 10. So this is the solution to the first part, profit maximizing output mix, that is x at x equal to 10 units and y equal to 10 units. Now for the second part, estimate the effect on profit if capacity is increased by 1 unit. For this we have to find out what is the value of our lambda. The lambda, as you can see from equation 3, it was 80, it was either of 80 minus x minus 4y or 60 minus 2x. So let's use the first equation, 60 minus 2x minus y. We put in x equal to 10, y equal to 10, 60 minus 20 minus 10. So this lambda comes out to be 30. So this is nothing but our shadow price. So now how do we interpret it? We interpret it in terms of that if output capacity is increased by 1 unit, the profit will increase by 30 units. So this is the interpretation. This is nothing but our shadow price. So this is how we solve using a constraint optimization solution. Now for more such videos, subscribe to my channel, like this video if you like it. Thank you so much.